Hello, everyone. Good evening, good morning, and good afternoon. So today we are going to talk about Model 6, which is optimize the model performance. So just developing a report itself is not a task of a data analyst. So we need to optimize our data model in order to perform fast. Because whenever we share our report to the end user, whenever they try to access the report, it has to load within 3 seconds. That's the usual report performance. If you have a big data and it's direct query mode, then that's a separate story. But generally, whenever the report you load, it has to be load within 3 seconds. If it is go beyond that, then you need to look for some optimization ways where you can increase the performance of your report. So today we are going to talk about the data model performance optimization ways and also direct query model optimization methods. All right. So first of all, when your data model is optimized, it performs fast, as simple as that. So the ideal solution for that is your system will work fine when you are accessing it in your local machine. So if you have a high-end machine, then and you are building a report in Power BI desktop, everything will look fast and looks good itself. But when you publish this into Power BI service and you share this with 10 users, for example, 10 users will try to access the report. In that case, it purely depends on the capacity what you have in Power BI service. So at least whenever user interact with anything, then it has to run the action and then it has to generate a query in the behind the scene and get the data from the storage in the if it is an import mode and then load it again into Power BI desktop so that user can see the difference of the visual. So these things happening in the backend and these things require some compute capacity. So that purely depends on your capacity. So if your model is not good enough, then report users can see the difference of the report loading on that. So there are various methods which we'll talk about that. So first of all, we need to ensure that the correct data types are used on your data model or not. Because sometimes even for the numeric, if you set this to be string, then it will pick up sometimes in order to load the data. So that only we need to use the correct date format if it is a date column and also the numeric and also the text column, whatever it is, we need to follow the same structure. And then delete unnecessary columns and rows. So if you have the requirement from the business that you need to show these many informations, after that also you have some multiple columns available on your table in a fact table. Generally fact tables are big in size. So in that case, what will happen is unnecessary loading of the information can increase the size of your data model, and that can lead to your performance impact on that because it has to load everything during the report interaction. So you need to delete that one, whatever you don't need the thing, the number of columns, you have to keep only this required column. Other columns you have to remove from this model. So removing from this Power BI doesn't have any impact on your data source. So you don't need to worry about that. You can get the data from the source and remove it here in Power BI. And also the rows also matters here. So if your report requirement is only they want to look for the past 5 years of the data, but you have a 20 years of the data, then in that case, it doesn't make any sense to show all the 20 years of data here. The business requirement itself is 5 years, then why we need to load for the 20 years of the data? So we also need to get the requirement from the business that how long the data they want to look into that so that we can load only those required data here. So that is also we need to keep in mind. And avoid repeated values. So if you have something is duplicating the information, then we need to try to normalize that and try to build a kind of star schema approach on that. And replacing numeric column with measure, these are the some things where we can make use of that. So if you have a numbers column, then we don't need that. Like if you have a quantity and rate it multiplied by value, then you don't need to have a value column separately on a table. It can be doable in the matrix in the measure itself. So these kind of things, if you have, then you can try to avoid that. And reducing cardinalities. So cardinality is nothing but about we can see the relationship between the tables. So if there is a unique value, we have a huge number of unique values, then it will have a performance impact. So we need to look for that information as well when you are looking for the performance optimizations. Analyze model metadata, and you have to check on that. So I will also show you that where you can look into that information. And summarizing data where possible. So for example, if your requirement is to have at a monthly level information, There are certain cases where even though you have the fact data as a kind of, for example, sales data you have for 1 month of everyday transaction information, but the business requirement is they want to analyze the sales performance by monthly level. So in that case, you don't need to bring even the day level data into your report for this particular reporting purpose. In Power Query, you can group by all the things, or even you can group by things in the source itself. If you're using relational databases like SAP or Oracle or SQL, then you can group by those views in that source itself and bring that data into your report and show it here. Then you will reduce the amount of data and it can lead to your increase in performance. All right, so how to use variables to improve the performance and troubleshooting? Before to that, so we can just check on that. So use variables to improve performance and troubleshooting. So the previous thing what we discussed, I'm going to cover that in future slides. So we'll continue on this one here. So use variables to improve performance tuning and troubleshooting. So let me just copy this visual, this measure, and then add it here into Power BI. So let's add a new measure, dummy measure here. Because it is not in a color format, so that's why I'm just trying to copy that. Generally, colors actually helps to read in an easy manner. All right. So we don't have that information here. That's the reason it's showing an error. I think, let me check the name of the measure here. It's actually total sales. All right. So let's replace this with total sales. Okay. Similarly, let's copy this here, paste few of them. Total sales. All right. So this has to be the dim date. Yeah, dim date custom. So I think this has to be full date alternate key. Yeah, correct. All right. So now we have this measure. So let's copy this and add it here. And let me copy this also. I can go through that from the same screen itself, but it will be hard to understand actually. So I forgot that. Total sales, and this should be dim date, and here it should be fine, full date alternate. Okay. So let's copy this also here and paste here. All right, let's delete this for now, and then I'll expand this here. So this is one measure, and this is the same measure, but in a different approach. So here on the top, what you can see without variables and sales year-over-year growth. So this actually does the calculation of year-over-year growth of the sales. So we are taking up here total sales divided by, and then minus calculate total sales parallel period of the previous month, minus 12, that's what we mentioned up here. So minus 12 months. And then we are comparing this value with the minus value, we are dividing again with the previous year value. That's why we are doing up here. But here the below one, it's actually hard to understand what actually it has done. But with variables actually, so variable, we are declaring a variable here. It's a kind of temporary value which you are going to store within that measure calculations here. So you're declaring VAR, that's a keyword, and then you need to give it a name here, and equal to, so I'm calculating previous year's sales in a variable and keeping that value in temporary variable here. And then I'm calculating the variance here. So variance is nothing but total sales, which is for this one. And then here I'm reusing the value here. So sales prior year and using the same sales prior year here. And whatever the minus value, I am using that to be divided by the previous year value. Whereas here, the total sales is coming up here at the 2 times, and here also 2 times, that's fine. But here, this one, the calculate of the parallel period, it is actually coming up here 2 times. But whereas here, we are just used 1 time and we are reused that. So the benefit of using this approach, and finally we are returning this sales variance here, is going to return the same value for us. So the benefit of using this approach is 2-1. One is it can increase the readability, so user can easily understand what actually it goes, and we can just go one by one here. And the next thing here is we can debug the things. So if you want to calculate the previous year, so we can check that amount here one by one. And also it can increase the performance. How it can increase the performance is because we are not calculating the previous year calculation two times, like it is happening here on the previous one. So we are just consuming it one time and we are just reusing the value from the variable. So that's the reason we had to use the variable for the three use cases, right? Like I mentioned, one is helpful for the easy readability. Another is it can increase the performance because we are reusing the measures. We are not calculating again and again. And the third thing is we can debug the thing. So how can we debug that? So these two things are easily understandable, that you can easily readable and we can reuse that. But how to debug that? So if I go back to my report here, so I'd like to give the name here with variable sales, same thing. So hit enter here. This is going to create a measure form. Now, if I want to debug that, there are two ways. I will also show you that. So here, let me add a card, and from that card, so let's add this measure. It is showing up 0 because I have not selected any year. So let's select here for 2019, for example. It's showing up 0.43. Actually, it is showing up in percentage. So I'd like to convert this into percentage, which can do it from the top menu here. But if you want to debug that, then we can just use here as, let me zoom this here. So sales per year, I am what the value here. Right now they're showing up the value 0.43 is basically the percentage of the sales variance. It is actually showing up this calculation. But if you want to calculate, show the what is the value of previous year, then you can just copy this value and paste here at the return statement. So I just want to return the previous year. So this is how you can debug the thing. Now it is going to show as the value of 2018 because right now I selected here 2019 and now it's showing up here 3 million, which is equal to 2018 value here. So that's the reason. If I select here 2020, now it should show 1.74. Yeah, that's what's showing up here, which is exactly showing up here. So now we can understand that this calculation works perfectly fine. And right now I'm also debugging with multiple selections. That's also a good option. And we can also see the information of sales here as well in the grid. And we can also compare it here. And if you want to check the total sales, we already know about that. You can just copy the total sales and paste it here. This is going to return as only the current value. Right now, I selected here 2020. So it will return as 6.54 million kind of thing, the value here. Yeah, you see it's returning 6.55. That's also correct. Now, if you want to know about what is the difference between these two, like previous year and this year, you can just copy the inner calculation what we have done here. So you can just copy total sales minus sales previous year, which is from here to this one, and paste here after the return. So whenever you are using a variable, then you need to use the return function as well. Then only this gas calculation will understand that. So we have a variable, which is a temporary calculation, and something you need to return after that. You're returning whatever you're adding up here is going to return the same value. So if I return this one, then I can see the difference between the 6.54 and 1.74. So it should return some value here, which is equal to 4.8. Yeah, that's what I mentioned here. So finally, this this is the value showing up here 4.8 minus, 4.8 divided by the previous year, which is 6. Here in this case, it should be I selected here 2019. Yeah, sorry, 2020. So 2019 is 1.74. So 6.54 minus 1.74, it's going up 4.8. And here 4.8 divided by 1.74. That's the return value which are going to come. So if I remove this here and just keep the sales variance, which is the last step here, and then hit enter, this is going to give us the value of the difference between these two and with the percentage here. It should be in positive because we can see the increase in number here. Whereas if I select on 2019, it's in negative. That's why it's showing up minus 0.43. So this is the advantage of using the variables where we can make use of this. All right. And the next thing here is the performance analysis. So find out how each report element is performing, measure report element during user interaction, and detect which aspect are least or most resource intensive. So the first step, whenever user complaint or you are feeling that your report is performing slow, this is the best tool where you can look into that. So you can find this information in the Power BI on the top ribbon under the optimize, you have this performance analyzer. Or if you're using a new layout of recent version of Power BI Desktop, then you can see it on the right side as well. If you haven't seen that, then you can just click on the plus icon. And from here, you can select this performance analyzer. So this is going to show up here. So once you click on that, it will open up a window here on this area. So you can minimize the other things which is not required. All right, so let's say we have this report, and in this page, we have multiple reports. Multiple visuals here, 1, 2, 3, 4, 5 visuals which is showing up here. And they are showing different metrics here, right? So if you want to monitor how these things work, then you can just open up this performance analyzer and then click on start recording. So once you do so, it's giving you the information, and from here, you need to click on the refresh visuals. So once you click on the refresh visual, it's going to load that visual. And now by default, I'm not able to zoom here. Yeah, it's not happening. All right, so here we have an option about sorting by duration here. On the right side, it is basically sorted by the total duration, action order here. And you can see the first one which is showing up here, everything is in milliseconds. So it means 1000 equal to 1 second. So this visual, which is this one, is actually showing up or taking up 1 second to load the thing here. But the slicer other things have taken up almost millisecond, more less than a second for that. So we need to worry about any visuals which takes more than 3 seconds if you are using an import mode on that, and we need to check what is the reason behind that. So here there are certain things which we need to see here. And whenever you select here, it's going to select the visuals also here. And once you open up the performance analyzer, you can see a new icon will appear to analyze this visual. If you just want to refresh only this particular visual, then you can just click on this icon, then you will refresh this option here. So now you see the first time has taken 1 second, and here now it's taken up very less one. So if I expand this option, now you can see the difference between these two here. So for the first one, which is a DAX query, so this is nothing but this query, even if you're using a direct query mode or import mode, both the time you can see the DAX query here. So what happens here is this formula engine, which is the responsibility of the generating a DAX query. If it is an import mode, then it will send that formula to storage engine and get the data from the storage engine and display it on the report view on that. But if you're using a direct query mode, then this will generate a formula, the SQL statement, if you're using relation databases, and then it will go to SQL Server and get the data and show it here on the visual. So that's the response. So every time it's going to generate a DAX query, and that has taken initially, which is 2.83 and 283, and now it's taken 103 here. So if you're reusing that without clearing the cache, then you will take some information from the cache. So that's the reason you can see it has increased in performance here. And the next thing here, we have option about visual display. So this visual display is nothing but how it's going to render that information here. This can be responsibility of showing the data on the visual. It can load the data from the web, or if you're using an image, something else. So those things it will consider as visual display here. And the next one here, what we have others here. So others are responsible for the loading. It will going to wait for other visuals to load here. So this we may not need to worry about much. We will just need to focus on the DAX query statement first. And the other things, yeah, we don't need to worry about this. So for example, if you have a less in performance, then you can just copy this query and then look into DAX Studio for that. But now they have given an option about DAX query view. So you can just click on this icon. Then it is going to open up the window of the DAX query from the left side. And you can see it has added also generated a DAX query for us. Even though the DAX query what we have used is not the same, but this is the way how this formula engine will generate the query and display it on the visual here. Right now, what we have used here, we have used here the filter to be North America, and this is the sales territory group. And after that, I use summarize column DAX function. It has summarized the calendar year, and it has taken the value of the North America table, and then it's going to display the internet sales, and then previous year and the difference percentage. There are 4 columns which we are used here, and that's the reason it has showing us the result in the 4 columns here and year by year here. If I go back to the report, now you can see I also filtered here the North America and no filter on the year. So that's why it's showing up every year, only filter on the territory group here. So you can run this one, but you cannot able to see any difference. I mean, the performance here. In order to look for the performance, then you need to use the external tools here. So there are certain external tools which is available for Power BI, which is one of them. Most majority of people are using the two things. One is the DAX Studio, another is Tabular Editor. So DAX Studio is helpful in order to see the performance of the formula engine and storage engine, whereas the Tabular Editor you can create calculation group, which you can also create in Power BI now, but previously it was not there. And also there have some best performance analyzer like 48 points, where we can go through one by one, and then we can try to optimize our model based on the standard practices international. So I can just click on the DAX Studio. These tools are all free. DAX Studio 3 is a freemium, which some of them are free, and we need to use paid version on that. But the Tabular Editor 3 is a paid version. Tabular Editor is a regular one, which is free of still. So now I'm using up DAX Studio, which is also free here. And once you click on that, then it will open up here the window where you can connect our data model. So it is establishing a connection here, and this is now connected. And we need to open a few things, which is server timings and the query plan. I think query plan we don't need here. We just need server timings, and then we need to clear the cache, and then we need to run this. So whatever we want to run, we can run here. So let me just copy this entire query and paste here. The same one I would like to run now. So now we can see the batch is completed, and this is the result. We can see the same result how we have seen previously. If I can able to zoom it here. Yeah, it's zooming. Yeah, that's good. I think this 200 is fine. Yeah, this is fine. Okay, so this is the query, and this is the result it has given up here. Now, if I click on the server timings, so here, oh, they have not given option to increase the size here. No issues. So here you can see we have a 33 showing up here. Total value showing up 33 million, and here we have FE and SE. So like I mentioned, we have a formula engine and storage engine. So formula engine has taken 75%, which is 25 milliseconds, and storage engine has taken up 8 milliseconds. So here majority of time it has taken by the formula engine itself. And to generate these things, Power BI has created 4 different queries. So now we can see the 4 different queries here. And these are the information which is showing up here, which is taking more time on that. So here in this case, this has generated 1,829 rows. It is actually generating a SQL state. So select date, full date, alternate key here. And again, it's giving the full date with the year calendar. And the third one is giving up everything, which is the full date alternate key with the sales territory table. And this is using up here another SQL statement. So by combination of these 4 SQL statement, and it has bring up into visuals in Power BI Desktop and displayed the result as our expected result. So these are all things which is happening behind the scene. So in this case, where you need to look for the information of the formula engine or storage engine. So if you are using a kind of large data model, if the storage engine is taking much more time, then in that case, you need to look for a data model optimization, where you need to look for the relationship, you need to look for the unnecessary columns or the data you want to remove, you want to aggregate. Those are all the steps you need to take care of that. But if you have a performance on the formula engine, then in that case, you need to look for your DAX optimizations. So sometimes the same result can be optimized, can be achieved in the different DAX. That's the beauty of DAX. But maybe in some cases, if you're learning of starting a Power BI, then you can chances that you are using unnecessary DAX, should not be used there. For example, here you want to remove the filter of all the regions, I mean the sales territory group. In that case, you can just use all, which is the DAX function, and then you need to use the sales territory group table here. Not the table, the column name. Instead of using the column name, if you use to remove the date, I mean the entire table itself, then it will have an impact on the performance. So for example, if I type it here, if I go back to this one and open up any measure, yeah, so here, calculate parallel period of this month. Here I'd like to go with all, which is the DAX function, and then sales territory. So sales territory. So here we have a sales territory, which is the table itself, and these are all the columns. So whenever you are using the all function, Unless if it is not required, then use only the required columns here. So I want to use all, and then this is the column I want to remove it. What actually it will do is it will remove whatever the filter applied on this particular column for this particular calculation. That's why it does. It means it's going to load you all the data from this particular column. That's important. Whatever other filtration applied on that table, it will apply, but only for this column, it's not going to apply that. Instead of using this with the column, if you just use only the table name, then it will just remove every filter on that particular table and give you the whole result for you. So if your table is small, then it will not have any impact on the performance. But if your table is big enough, even I have worked on a project where the fact table itself contains millions of records. So in that case, if you even the dimension table itself contains millions of records. So even in the dimension also, if you want to remove something, then you need to specify the column name, unless until if it is not highly required. So that's another thing which you need to keep in mind. And here I can close this. All right, and then what we have. So that's where we can analyze the performance, analyze the use of that. And these are all the duration which we already discussed on that. And also we have used analyze query plan. So here is an example of that. So for this one, like I said, we can achieve the same result with the help of different DAX functions. So here are two examples which has given here, count customers. So if I copy this calculation itself and go to DAX Studio and then paste here. So we need to define that, or else we need to evaluate, and then if you're using DAX Studio, then you need to use the evaluate initially, and then we need to use this one. And if I use this option, because this is going to return me one value, distinct count, so I need to return this in a table. So DAX Studio will return only in tables, not a static value. So I need to clear the cache, keeping the server timings, and run this. So I need to use the row function, which is okay. Result, and then command. So this has to be this one. Oh, sorry. So maybe this column is not available on this one. So let's try to add it here first in the report. Yeah, that's just an example. So I need to use that information here. All right, we measure. Fact internet sets. All right. So all right. So let's give it a name here. So let's add a table, fact internet sets. And then product key. All right. So filter, I'd like to use the fact internet sales. And this has to be order quantity. So this has to be order quantity greater than 0. So this is the measure which has to be there. So let's copy and paste here. Yeah, it's running up now. So now this has taken like formula engine 57. So let's first of all see the result. It's showing up 0. Yeah, it doesn't matter if the return 0 or not, but we need to focus on this here. It has taken 57 milliseconds. It has taken 13 milliseconds for this. And it has generated one query to get this result. Whereas the other one, which we have used here, calculate distinct count and then this formula. So let's I'll comment this one. Comment this here, fact order, and then this is the one. And key filters, and this has to be fact internet sales, order quantity to be greater than equal to 0, 5. All right, so if I run this one, so let's take a screenshot of this one. So if I run this one again, so now you see it has showing up your formula engine to be 54 and then 10. So there is slight change here. Total overall is 64, and this previously it was like 70, and formula engine like 54, and this is 57 previously, and storage engine is 10, and it's showing up here 30. So this table, which is I'm using up here for this demo purpose, this is actually very small table. So let's me load this one. I think this contains only 6,600 records. Oh, no, the 60,000 records kind of. Yeah, you can see it here. It's 6,398. So this is a small data set. Let's see, we have it here. So even in that itself, we can see a slight increase in the performance of this using a different measure. So this is how you can able to debug your DAX performance, DAX query performance, how it should work. And both the thing, it will work in the same way. The result output is going to be the same. So either you can use this or that option. So you need to make sure about using a different DAX, right, or different DAX. This will only applicable if you're working on a project and if it goes like the performance is low, then only you're going to do these kind of debugging options. All right. So let's talk about this cardinality issue here. And if I go home tab, so I just open up here the Power Query window. So where we can able to see the column profiling of these things. I think we have also seen the previously, but still I will show you that. For example, if I open up here the dim customer, or yeah, it should be dimension table itself. So view, and then you can open up this column quality and then column profile, directly give us information about the column values here. So on this one, if I just select the first name of this user, and here you can see we have a distinct value and unique values here. So what does it mean by distinct and unique value? So distinct refers to we have a distinct number of values on the total 427. Totally, it's showing up the information about 1,000. So 1,000 values have a distinct 427, and others is going to repeat that value. Whereas this 174 is showing up here has it come up only a single time on the entire thing here. It has not come up in the multiple times here. So it has come up only one time, which is unique value here showing up on this one. So the more you have a unique value, so it will also have a performance on your report. So if this kind of things happening on your report, then you need to reconsider about whether you want to keep this inside to this table or you want to keep it in a separate table, the first name alone, and then you can link it with the numeric key for that. So relationship building between a string key, it has a little bit in terms of performance impact, which I have feel in my experience. So usually the relationship should be based on the numeric key itself. You can give it using a text on the date column, but using the numeric integer key is a good way to help in the performance here. All right. So, and also we need to have an implement table granularity. So what happening here in this example, let's say, for example, you have a calendar table, which is going through daily basis. And then you also have a sales transaction table with you. So in that case, you can easily connect your date table and then sales transactions with you so that you can compare those things here. Whereas if your budget has only the monthly level information, in that case, how it can be achieved. So if you want to compare the monthly sales versus your monthly budget, then how it can be possible. So for that, the other way of doing that is either you can connect your month column to the budget, but this will have your many-to-many relationship between the calendar and budget, which is not a recommended one. And then you have to use the direction from calendar to filter to the budget table. Instead of that, you need to use another column, create a column where you can have the beginning of the month for that column. So you can have a 1st of January, 1st of February kind of thing. So you can use the date itself and then you can link between that. So when you visualize that in a monthly level, then you will see the correct data and the report will also have a good in performance. I think we have a part of relationship in the upcoming things. Yeah. I think we also covered in the previous session itself, correct? All right, that's the thing here. And the next thing is optimizing direct query models here. So whenever there is a requirement that you need to get the near real-time data from your source, then you need to use a direct query. There is no other option because import need a manual refresh on that. So in that case, we can connect to your SQL Server or any data sources which is applicable. You can have, while you are getting the data, you will get an option about whether you want to import it or direct query mode. So here you need to use the direct query mode option. So there are certain benefits and limitations of using direct. So what are those? So you need to use a directory whenever your requirement is to get the data recently from the source. So the requirement from the business is they want to look the recent sales transaction happening, like for example, the stock market. So that's the kind of near real-time information which are showing up on any stock website. So it's continuously changing the values on that. So during that time, we can use that option. And if the if your data volume is very large, like it can go like millions of record or billions of record, in that case, its import mode is not applicable. So if you're using a pro license, then more than 1 GB of the data is also not applicable. In that case, you need to go with the directory mode itself. And it's also support multi-dimensional data, like if you're using a SAP, BW, or analysis services, then you can also connect live through that. So when you're using multi-dimensional data, you cannot able to import the data into Power BI. You can just able to connect live through that. And the limitations are there. So the performance will have a depends on underlying data sources. And not only data sources, there's also other factors like internet connectivity as well. So if you don't have a good connectivity, but your high-end server has a good connectivity of the internet, then even though the server could use a good result, but your system will not receive it fast. And also, if there are users like 10 users or 20 users are accessing the report at the same time, and you have a 10 users on the report, and this time, like I mentioned earlier, so this time this will generate a query. So 20 users into 10 users will generate 200 queries and send it to SQL Server, for example, direct query mode, and get the data from there and display it on the report visuals. So accessing 20 queries at the same time may have an impact on the performance if the server is not good enough. So it purely depends on the server response. So it can happen deadlock also. So you need to maintain that here in order to check the performance of that. Or also security, understand how the data moves between the source and destination. So security can be a good point. So if you're using a kind of high security feature, then in that case you can use through that VNet gateway or other options available. So it can use a private network on that. And modeling, some modeling capabilities are limited and aren't supported, and some of the DAX functions also not supported if you're using a direct query mode. And some data transformation techniques are also limited. You are not able to do much transformation happening how you usually do using an import mode. It's not possible when you are using up here in the direct query mode here. So there are certain things where you can help in order to increase the direct query performance, where you can just check with the performance analyzer first, and then you need to check the data source, and then finally you can go option to reduce the reduction here. So while you are developing this report in direct query mode, the newly given option here, if I click on optimize on the ribbon, I have the option about pause visual and refresh visuals. So this is actually a cool feature. Like whenever you do some changes, like selecting a slicer or interacting with any visuals, usually it will just start to run this visual. Like if I do it here, then you see it's actually changing the value here. If I do it something here, then it's going to change the value on this visual. If I select anything on the slicer, then it's going to change on this visual. Then this will actually keep on sending the values to the direct query to server and then send the information. While you're developing on this report, then you have an option about pause visuals. So if I click on that, then if I do something changes on this one, this is not going to have any impact on that. You see the visual has pending change that is showing up any value. So it's not giving me any result here because I have just paused the visuals. Now in order to resume that after selecting these things, then I can click on the refresh visual option. So this will be just temporarily to refresh that value. But if you want to refresh everything, then you can just click on untick this option, the pause visual. So now this will refresh everything. That's one way. So here we have option optimize preset. How you want to, this is applicable only for the direct query mode options. How you want to do that. So you want to use the query reduction options. If I zoom in here, so here we have an option about query reduction. This preset turns off cross highlighting and cross filtering and add an apply button to filters, usually best for direct query connections. And this is the interactivity. This preset allows cross highlighting and cross filtering as well as a real-time slicer selection, usually best for import mode. So right now is import mode, so I'm using this one, and if you can change based on your selection. And also we have given option here, apply all slicer button. So once you click on that, then it will add up here on the screen. So whenever you make any changes on this one, then nothing will happen to the other visuals. So you need to select first whatever you want. If you have a 10 slices, then you can select 10 slices. And then you can just click on apply all slicer button. So once you click on the apply all, then only it's going to apply that filters to your visuals. So this is still grayed out, I think. Yeah, it's filtered. Yeah, now it applied here. So I think it was not pressed correctly. Yeah, we are using a Power BI desktop, so we need to use the control click. So I was just clicking on that, so that's why it's not working. So if I change again for 2020 here, and then just select also the Europe on this one, and click on apply all slices. So now you can see the two information showing up here. That's pretty cool. So this we have seen on these options, and this is the query detection. So now we have just talked about the cross highlighting and cross filtering. What does it mean actually? So whenever you are selecting anything, not the slicer part, let me clear the slicer here and apply all slicer. So as you can see it here, where this is showing up here. So let me just close all these things. Yeah, and then I will zoom this here. Oh, that's too big. So you can see we have a here selection here, and also we have here on this part. So if I select something on this visual, which is on the matrix 2020, so it is actually highlighting this value here, right? It's just disabling the dull color of the other things, and it's just showing up highlighting on this particular thing. If I select on 2018, then it's showing up 18 here, and it's showing up dull everything here. If I select something on this part, like 2021 on this one, or if I click on this particular thing, it has gone to the designing mode. So if I click on this part, I think access is not working. So if I click on any of the slicer, then it's filtering this value here. So the previous one, what I have shown is actually the cross highlighting. It's just highlighting the value, what I selected here. And this time it filters the entire visual. So this is actually the cross filtering option. So we have an option to disable that in the settings, because if you don't want this thing to happen, then you can also make use of that. So that can be done if I click on the file and options and settings, and then options. And that is, we need to go here at the bottom and query redaction. We cannot change it globally, so we can change it for a one particular report. So here I have the query redaction, and here we have an option cross disabling, cross highlighting, cross filtering by default. So that's the thing. If you want to add, you can also use that. And here also we have an option about instantly apply basic filter changes. So that's what the pre-settings. And now we have used the apply all slicer on the visuals. So it's not going to apply any filters. Only after clicking apply all slicer, then it will work on that. All right. So this is the pre-setting which you can use. If I go back to this report. Yeah, I think we have covered the topics which need to discuss for today's session. If you have any questions, you can just let me know and we can discuss it on further. Let me stop share.